share it later. All right, there we go. I think we're recording.
Yes.
So we are happy today to have Dr. Parisa Kloss.
Yes.
Dr. Kloss is a trained architect and urban designer and planner with more than 20 years of experience in the Middle East, Asia, Africa, and Europe. She is also the founder and executive director of Resilient Urban Planning and Development in Berlin, Germany. Parisa is an expert in urban climate change planning, urban heat island effects, and sustainable and resilient cities. She has also some collaboration with UN Habitat, United Nations Habitat, as an urban thinker. Parisa, can you please explain about your collaboration with United Nations Habitat a little bit more to our students? And then we can start the presentation. And thank you so much for joining us today.
Yes,
we are so
sure.
excited, to learn more about heat island impacts. And thank you for sharing your experience. So please.
Yes. Good morning, everyone. First of all, thank you that invite me to this session. It's my great pleasure to be here today with you. And also thank you, Dr. Soflai, for your kind introduction. So regarding to UN Habitat, I'm mostly contribute with World Urban Campaign is one of the initiatives of UN Habitats that they're constantly organizing the urban thinkers in different cities around the world to somehow promote the sustainable development goals and also new urban agenda, and they're trying to achieve to zero carbon and 1.5 degree less in their cities by 2030. So this is what I'm doing, and until now I already organized the 3 urban thinker campuses with collaboration of Malaysia, Municipality of Malaysia, also Mannheim city in Germany, as well as India, Nagpur. There were 3 urban thinkers that we already organized, and we want to continue that in different cities around the world. So if it's enough, I can start my presentation. If you have any.
Thank you very much. Thank you.
Yes, yes. Today, I would like to talk a little bit about what is exactly urban heat island phenomena and what kind of effective factors can contribute to the intensification of urban heat island, what kind of negative impacts urban heat island can have on different aspects of life, what kind of adaptation strategies we can use to tackle the issue, as well as introduce you 4 projects that might give you some ideas or points for your design projects. What is exactly the urban heat island phenomena? So basically, an urban heat island is a climatic phenomena in which urban areas manifest higher air temperature than the rural surroundings. So the heat that is absorbed during the day by building, roads, and the other constructions can be emitted after sunset, creating the higher temperature differences between urban and rural area that we are calling it urban heat island phenomena. To explain it simply, urban heat island effect resulting from the production and accumulation of heat in urban mass. Urban heat island, as I already mentioned, have different negative impacts on different aspects of life. It can impact on environmental aspects of life, like, for example, air quality. How? Urban heat islands are especially problematic in urban areas that already have difficulty meeting air pollution standards and increase the possibility of formation of smog, which created by photochemical reactions of pollutants in the air. Basically, the formation of a smog is highly sensitive to temperatures, since photochemical reactions are more likely to occur and intensify at higher temperatures. It can impact on social aspects of life, like the health of the citizens, so it can be a tremendous threat for the health of the citizen, especially the vulnerable people like elderly, children, or the people who have a serious health issues. Or it can impact on economy, aspects of life, like waste of natural resources. Like, for example, higher temperatures in cities increase cooling energy consumption and water demand for landscape irrigation. So this will increase the peak of electric demand. As a result, we need more, we need to produce more electricity or more energy, and this will trigger the release of more greenhouse gases due to combustion of fossil fuel. The exact form and size of this phenomenon varies in time and space as a result of urban characteristic, locational, and meteorological factors. Basically, the urban heat island morphology is strongly controlled by the unique character of each city. Do you have any question?
No, we are good.
No questions yet.
Yeah.
Yes, sure. If you want to ask any questions, you can interrupt me, no worries.
No, we are good now.
Okay, so basically, how big is our city? How is the population size? How dense is our city? How is the urban geometry? The materials that we are using in urban areas, are there low albedo materials or high albedo materials? They are dark. What is the albedo? Albedo is the rate of reflectivity of the materials. If we have a higher albedo materials, it means they can reflect the solar radiation and send them to the atmosphere and try to cool down the city. And they're not absorbing it and they're emitting it after sunset, creating these higher temperature differences between urban and rural areas that we are calling it urban heat island. And even urban activities occur in urban areas can be responsible for the urban heat island intensification. Or where in this world are cities located? Is it near the river? Is it near the sea? How is the topography, the altitude? Is it surrounded by mountains? Or meteorological factors? How strong is wind speed in our cities? If we have a strong wind speed, it can take out the pollution and also heat out of the city and cool down the city. If we have a low wind speed, it can contribute also to accumulation of heat and pollution over the city and create a dome of stagnant warm air over the heavily built up area and increase the intensification of urban heat island. Temperature anyway is going to help on intensifying the urban heat island, humidity, precipitation. So there are the different factors can somehow contribute to intensify urban heat island. But I'm not going through each of these factors, but if you have any questions, I can open it up. And I would like to immediately dive into the measures that we are using to adapt to urban heat island effect, and then introduce you the project that might give you some ideas for your design project. This is the classification that I did. I divided different measures in three categories: physical measures, technological measures, social and cultural measures that we can use to tackle the issue. But actually, this is my classification. You can come up with a new classification. For example, the physical measure, like using building greens, green walls, green roofs, urban green areas connected to gray infrastructure, green corridors, street trees, house gardens, parks and natural green areas, community gardens and green indoor areas. Blue areas like river, lakes, you can, if you have a river in your city, you can bring a part of the river into that target area and cool down a little bit that urban area. Using the natural material or high albedo material, permeable surfaces, cool roofs, cool pavements, using different shading devices. There are the general physical measures that you can use, but depends on the context of your city, you can come up with the new or even innovative measures to tackle the issue. Is not, we are not saying that you should definitely use these measures. But this is the general or, already proven measures that you can use in your cities. And these green and blue measures can be classified under nature-based solution that we are calling it NBS. And using the green and blue measures are not something new. And for centuries, we use this kind of measures to cool down the cities, or the people cool down themselves. But recently, they come up with a term that they are calling it nature-based solution, and they classified all these green and blue measures under this category. But in my opinion, nature-based solutions are not always the best answer. For example, planting non-native trees to offset carbon emissions can be detrimental to biodiversity, and can even reduce the availability of water, and the potential climate benefits do not outweigh the cost. It is important that we make science-driven decision to apply the right solution in the right place. This is really important, that we have to pay attention. So, and nature-based solutions are not the only solutions we should use to help communities or countries adapt to climate change. In my opinion, it is best to invest in a diversified portfolio, and not to put all your investments into just one solution. Use a range of strategies that complement one another. Nature-based solution can be key assets in a diversified portfolio, but you can also come up with the other solution, depends also on the context of your city. I'm all the time saying that don't put your eggs, all your eggs in one basket. Try to distribute them, because if you are choosing a different kind of solutions, they can have more impact than that area. And the other measures, other category of measures is technological measures, like using the intelligent facade that can adjust itself based on the solar radiation, and also integrated solar panels. But again, it depends on the context of the city. How robust is our infrastructure? How robust is our system that can accept another technology on top? Is the infrastructure not vulnerable, or if we are integrating another technology on top, can be more vulnerable? In that case, we have to upgrade our infrastructure and then integrate technology, or integrate technology for the new buildings from the beginning, or using the sensor to adjust energy consumption and energy consumption in buildings, and water-based technologies, technological tools and big data. We have two different technologies that we can use, like, for example, using technology as a physical measure that can be integrated in infrastructure and system, or using the technological tools and big data that can help us to identify the hotspots in the city in the best way, and take a sustainable and smart actions toward the reduction. So basically, this technology already improved and can give us some kind of opportunity to facilitate or ease the process of identifying the challenges, and also developing different scenarios to tackle the issue, or using developing different apps, like, for example, where are the hotspots, when is hot, like we shouldn't go out, or what kind of clothes we have to wear. This kind of apps also exist that can give us some ways to avoid some health issues, especially for the people. And in parallel with the physical and technological measure, we are also doing using actually social and cultural measure in our project, because it's not just about physically intervene. We have to also non-physically intervene. If we just come up with some measures and physically implement them and forget about the non-physical stuff, like, for example, the people's lifestyle and behavior, we cannot achieve our sustainable development goals. So we have to constantly raising awareness and building the capacity of the citizens, because they don't know what's happening, what's going on. And on the other hand, climate change is a kind of invisible phenomena, and they cannot really see the impacts of this phenomenon on different aspects of life, and they don't know how it can damage our different aspects of life in long term. So we have to constantly, by organizing workshops, training courses, or different ways, try to raising their awareness and also building their capacity, and tell them or promote them sustainable lifestyle and how they should behave in the city that can help us beside physical measures, also helping us to achieve the sustainable development goals. It's not only about the citizens, also decision makers, even high rank people in the governmental organizations or in municipality, or they don't know what's happening. Sometimes you have to also organize lots of workshops for decision makers to inform them what is exactly the climate change. This is also another problem. The other, for example, measure that we are using in this category, engaging citizens in designing and decision-making process, because the people who are living in that part, for example, in your project, the people who are living there, they know what is the problem, because they are touching the problem every second of their life. As us, as we as an outsider, you know what I mean? So it's good that we bring the citizen into the conversation. We listen to them. What is exactly their challenge or problem? And sometimes among their conversation, we can come up with some solutions that we can integrate it in our design. So this is also really important. So basically provide a platform for co-creation, bring them around the table and together try to design something that is useful for them. And beside all these measures, we can also encourage energy efficient strategies through funding and incentives, promoting sustainable and green lifestyle in different ways, and promoting circular economy and many other measures that I didn't mention it here. So in parallel with physical and technological measures, we are also concentrating on social and cultural measures, but I'm not going to details of this measure, and I would like to concentrate on physical and technological measures more by introducing the different projects. I have selected 4 projects to present here. 2 design-based projects used more physical measures, and 2 technology-based projects mostly use technological tools to develop a platform to identify the hotspot, prioritize them, and develop scenarios to tackle the issue. So maybe these projects can give you some ideas. Sorry. So the first project that I would like to introduce you is located in Abu Dhabi, United Arab Emirates. The measures that we use in this projects are mostly focusing on green and blue strategies like nature-based solutions. We also use the natural and high albedo materials, permeable surfaces, using the different sorts of shading devices, as well as water-based technology. So I'm going to introduce you this project here. You can see the site that we have to intervene in this part. So the air temperature is around 39 degrees centigrade, and the land surface temperature of this vacant land is 60 degrees. It's like the asphalt of the street, which is also 60 degrees. And also 59 degrees centigrade, the land surface temperature of the pedestrian area. So sometimes actually—
Can I just jump in for a second?
Yes.
Because I just, only because, you know, I don't know what Celsius means or centigrade or whatever. So I just did a quick conversion. So 39 degrees is 102 degrees Fahrenheit.
Mm-hmm.
So just want to put that out since that's what our students will understand. And 60 would be 140.
Yes. Yes, and sometimes it can reach to 80 degrees centigrade, and you can give it a try. If you are also in a really hot urban area, you can cook the egg on top of the asphalt. This is also one of the issues in these kind of areas. So you can see that this is actually the site that we have to intervene. It's surrounded by buildings. It's a jungle of the buildings, and the greenery already crowded out. So the height of these buildings are ranging from 28 meter to 67 meter. So the challenge in Abu Dhabi is throughout the year, Abu Dhabi experiences a wide range of thermal stress level, typically between actually, I mean, ranging from 9 to 26 degrees centigrade to above 46 degrees. So basically, one of the most challenges in Abu Dhabi is have extreme heat stress, that we have to tackle that problem. And of course, it's happening between April to October. There are the hottest months of Abu Dhabi. Before actually we start our design, we took a look at different local architecture, structural elements, or even phenomena that can help us to create a structure to cool down the city, and it's coming from that context. So we inspired by oases to mitigate the urban heat island effects and provide thermal comfort and a pleasant environment for inhabitants. And oasis phenomena is one of the phenomena occurs in desert areas. What in Abu Dhabi is also happening. And so we inspired by that. And oasis is a green area in the middle of desert, centered around a natural spring or a well. It is almost a reverse island in a sense, because it's a tiny area of water surrounded by a sea of sands or rock. And basically, the oasis effect refers to the creation of a local microclimate that is cooler than the surrounding dry area due to evaporation or evapotranspiration of a water source or plant life, and higher albedo of plant life than bare ground. So basically, we inspired by this oasis, and we try to create another oasis in urban area, not in desert, in urban area. So here you can see in this picture, so this is our oasis in this urban area surrounded by these buildings. And we try to design a public space with different function. And this public space with 40 meters structure that combines physical and technological measures to achieve high impact in that area. We try basically to tailor the modern architecture and state-of-the-art technology to the local context through the structure, shape, and its detail. Here you can see in this side that how it looks like from different angle, the structure, and at the end it accidentally looked like a shape of a tree. We didn't want to design shape of the tree, but it accidentally happened. Physical measure that we use in this project, like we use nature-based solutions using natural and high albedo material, hollow and light structure that cannot retain lots of solar radiation and can act as a shading devices, not only on the structure by itself, but also on the surrounding sidewalks in these parks, and also the parking lots that is surrounded this area. Also, we used a technological measure like, for example, water-based technology for irrigating the greenery. So to keep the oasis always green and alive, water and irrigation system are really important. So we have to come up with the idea how we are going to irrigate this public space that we created. There are several ways that can be employed to irrigate the oasis. The main one is using gray water generated by surrounding buildings. So we try to connect the irrigation system of the oasis with existing gray water collector system of the surrounding building. We can solve the water shortage. And source of gray water are mostly sinks, dishwasher, washing machine, shower, baths, and they are contain fewer pathogens than domestic wastewater, so they can be easily used for landscape or crop irrigation. So the infrastructure of Abu Dhabi was also modern and robust enough to accept this new technology, so we didn't have a problem with that. So located between buildings, the oasis creates also many environmental, economy, and social, as well as aesthetics benefits for the local neighborhoods. So we try to see all the aspects of life. It's not just we're trying to mitigate the urban heat island effect and try to have environmental impacts. We have to, if we want to achieve the sustainable development goal, we have to consider all different aspects of life in our design. So, so this project could mitigate the urban heat island effects and cool down the urban area by distributing greenery onto different levels, or by elevating the oasis. Evapotranspiration is increased, which contributes to create lower temperature spaces in an urban area. And since the urban heat island occur in different levels, this is also really important. We have to think that urban heat island is not happening on the air. It's happening on different levels, ranging from subsurface to the air. So the elevated greenery can mitigate the urban heat island effect in all the levels through the vertical mixing of air, and can improve air quality indirectly through the reduction of surface temperature, and also reduce thermal air movement. Another benefit is reducing air pollution and improving air quality. The mixture of local trees, bushes, smaller plants, and flowers is extremely helpful in reducing air pollution and improving air quality. We should bear in mind that we have to use the local greenery that can be really useful because of the biodiversity, because there maybe is not useful in that climate, and so on. And also providing a platform and open space for communication, interaction, and well-being. So the oasis revitalizes the streets for walking, gathering, and recreation. So it's also accessible from all the sides of urban area. It can also have economic benefits. So it can have economic benefit in two different ways, directly or indirectly. Directly is like that the oasis invite the locals spend their time around the space, which opens up chances for shops, cafes, restaurants to increase their businesses nearby, and additionally open air markets like music events or sport groups can benefit from the cooler temperature and shading, and increase pedestrian traffic. So by organizing this festival, we can directly increase the economic benefit, and the cash flow can also come into the public space. I will explain it later. Another huge economic benefit is the raising, I mean, this is indirectly, but it can be also considered as economic benefit. That is the raising land value around parks or greenery, as people usually are looking for apartments near areas of greenery. Or another indirect economic benefit can be the decrease of energy consumption of the surrounding buildings, as the oasis has a cool down effect on its close neighborhood. Speaking from practitioner perspective, I will give you some hints that can be useful for your projects or for your future projects. If you want to convince a developer, investor, or a government or organization that your project has tremendous benefits or advantages in that area and can tackle the issue in the best way, and you have to, I mean, to implement it, you have to bear in mind that from a very beginning of design, think about how applicable your design is. And how can you overcome some of the implementation barriers from scratch to the end? There are plenty of barriers that always stop implementation of even very good ideas. So when, for example, like when the people are investing in urban nature, or the design that is connected to the nature or integrating the nature in that design, they do not always know what they get out of that, I mean, from financial point of view. And partly that's because they lack kind of the evidence of how is urban nature helping me reach my goal. This evidence is very depend on the context, and secondly, it's hard to put it into the kind of monetary terms. Because financing urban nature resolution is the big challenge. So there is no direct cash flow is coming into the into this public space. So maybe the the investor gonna think, okay, it doesn't have any beneficial financial benefit for me, so I have to forget about it. I wanted to reach to this point that when we are designing, we have to also think what kind of economic benefit that public space can have for us, or design can have for us, in order to convince the investor to implement it. And last but not least, static improvements in this project would also help on the static improvement. It is like an urban landmark that offers a surprise for pedestrians and also attract tourists through its unusual and Ethiopian appearance. And I would like actually to show you a video of this building that can give you an overview how this building looks like from different angles. And what I explained, you can maybe you can see it in this video. Actually, from an urban climate change planning point of view, the structure can interrupt microclimate changes in the urban canyon through its shape and characteristic. You can see it in this video, decrease the anthropogenic heat and the energy consumption in the surrounding buildings that I already mentioned. And the place offers, I already mentioned, a real surprise in that urban setting for people who stumble across it accidentally, and becomes a meeting point for various people, as oases have been in the past. In fact, these sorts of surprises can act as a magnet and distract the people from the harsh, still urban area with hot climate, and it lets them enjoy a comfortable, cool zone, as well as it increases the inhabitant satisfaction and their health. However, it is impossible to tackle the urban heat island effect in whole Abu Dhabi just by implementing one project in an urban area. For this reason, we also thought about the replicability of the idea, and the hollow and prefabricated structure that you can see here has the potential to be extended, adjusted, and replicated in various urban areas based on the form of the vacant land that we want to intervene. This can provide plenty of urban oases and lungs to let the city breathe, cool down, and move towards urban climate change resilience. And you can see here we also use the local actually greenery and try to provide a shadow, and also we use water to cool down this part, as I already mentioned, by using the gray water from the surrounding buildings. So this was the Abu Dhabi project. Is there any question until now?
No questions yet, I don't think.
Okay. Next project I would like to introduce you is located in Greater Cairo, Egypt, in one of the unplanned area, or we're calling it informal settlement area of Cairo, called Imbaba. Imbaba is selected as it is a prototype for highly dense unplanned areas in Greater Cairo. In this project, we use also mostly green and blue measures, and as well as shading devices, permeable surfaces, high albedo materials to decrease the temperature in this part of the city. So before we start, we try to map the land surface temperature to see very exactly the hotspots, somehow orient ourselves to find out where the hotspots, where are the priority areas to take action, and then find this hotspot and try to take action. For example, here you can see the vacant land spatially, and the places which has lack of greenery are somewhat suffering from hotspots or from high land surface temperature. So we came up with an idea to design. Here is the place. Here you can see the vacant land here beside the Nile. So we came up with an idea to design a chain of cooling public spaces as breathing points in a very compact area of in Baba, starting from these vacant lands along the Nile, as one of the most important potential of Greater Cairo, and followed by further intervention into the target area, which is hotspots are located, and then extended into the alternative vacant lands, one in the south of the target area, and one in the north part of the target area. So before we start designing or coming up with the idea, we also took a look at the different traditional architecture or elements of Cairo or Egypt to see that what they traditionally use to cool down the city. So we found out there is one structure called Takaiba. Takaiba is usually covered, it's a kind of wooden structure, and it's covered with plants to provide shade and breeze for cooling down and relaxing on really hot days of summer. And traditional material that they use for Takaiba is mostly palm trunks and fronds. They're really common. And this, we used actually this concept as one of the elements in whole process of design, from details to generalities. So here you can see actually we try to design a chain of cooling public spaces from this vacant land along the Nile that I already mentioned, and trace it a little bit in that urban area and reach to the other vacant lands in north and south part of the city. So here is, the idea that we came for the vacant lands along the Nile. Actually, this project, I should mention it before, that this project is still in the process. We come up with some ideas. We publish it as in one of the books, actually, this idea. And then we, because of the lack of time and budget, we are constantly raising a fund, and we are trying to continue this project that I will mention later as well. So by designing this chain of cooling public spaces in different scale, we try to provide thermal comfort for the inhabitants, especially the people who are vulnerable to climate change and have less access to basic services and infrastructure. The people who are living in the informal areas are somehow struggling with less access to basic services and infrastructure. By creating this kind of public spaces, we can provide opportunity for them to actually use this kind of spaces to decrease their vulnerability and also increase their health conditions. We also try to boost rehabilitation along the Nile, as I already mentioned, as one of the potential lands one of the potential elements of Cairo, and reestablish high quality urban life in that part. And here you can also see we elevated the greenery, and we also use the Takaiba style for designing this kind of shading devices. And what else I can mention here? So this elevated greenery also provides opportunity for more secluded, less polluted, and less noisy spaces for informal recreation. Basically, in informal settlement is not just about decreasing temperature, because you have to also provide, especially in Cairo, that people like to come out, meet each other, see, talk, so interact with each other. So we have to also create a public space that they can use for these kind of purposes. And also utilizing the different greenery levels and its garden as terraces for human interaction can contribute to the renewable of urban areas. And this structure will provide maximum shading, good viewpoints, and cozy places to relax and interact. So visual and physical contacts with plants anyway can help on the health of the people. So, however, it is impossible to tackle the urban heat island effect in entire Greater Cairo. So, as I already mentioned, we are constantly trying to raise funds to constantly work in different urban areas of Greater Cairo, even planned and unplanned area in both of them. And here is one of the areas, Bahtim, located in this part. That this is our next project that we are trying to design a public space in that area with a group of students in Cairo University, and I also have another lecture tomorrow with them. And we are trying to one by one try to come up with the idea for different actually urban areas in Cairo. So the next project that I would like, I mean, this 4 projects that I'm introducing you, each of them are different and they're giving you a different ideas. For example, how we can design in informal areas, in unplanned areas, how we can design in a really modern city, how we can use the technology tools to identify the hotspots. So basically each of them, I put it 4 different projects that you can come up with more ideas, or you can get maybe more hints based on that. And next project is located in Tehran, Iran, in one of their urban districts, Urban District 6. In this project, we use mostly technological tools and big data, as I already mentioned, to identify the hotspots and prioritize them and try to take up sustainable and smart actions toward their reductions. And we use also urban greenery, use the green corridors, cool pavements, cool roofs, shading devices. But in this project, I would like to tell you the scenario that we develop for using different kind of shading devices. Not only concentrate on the greenery, but also the other measures to show you how you're actually testing different scenarios and choose the best one that has best impacts on that area. So first, land surface temperature can give us the general overview, finding out where are exactly the hotspots. I mean, hotspots from the land surface temperature point of view. And then we choose one of hotspots, which is located in this part of Urban District 6. And then we use a spatial climatic analysis. Analysis is a kind of computational platform to identify the hotspots, or let's say to map the climate on urban fabric and building skin. The actually heat is not just happening on the surface, on the 2D surface, like for example, roofs and street. It can also happen on vertical levels in different facade openings or shading devices. So we have to use a kind of spatial climatic analysis that can give us an idea that where are exactly the hotspots. So here you can see the really dark reds are really hotspots, and also the ceiling, the roof of the buildings are also really hotspots, because in Tehran, they're mostly covered by asphalt, which can absorb lots of solar radiation during the day, and they're really hot. So as I already mentioned, there are the streets that are really hot. We use the green corridors to decrease the temperature in that part. But here I would like to concentrate on one of this scenario developments. Here is the one complex, a residential complex called ASP. And this roof is a kind of terrace. It's one of the terraces that it's look really hot. So we try to test the different shading devices in that part to decrease the temperature in that part. So in order to develop the scenarios, we have to test the different, we have to develop different scenarios. So to test how different forms, orientation, height, volume of shading devices can impact on that hotspot. For example, here you can see that, for example, we test different different size of this shading device. You can see And here is, I mean, you can see that by increasing the size of the shading devices, it can have better impacts. And then we test a different orientation with which orientation can give us the best impact. And then the next one, we try to test that which height can give us the actually best best impact. Here you can see that this height with this form, this orientation has the best impact on that hotspot and create a really big cool spot under the shading device. And also when you're standing in the middle of that, you can also be safe from the reflection of solar radiation from the surrounding areas, from the surrounding buildings or areas. So how we are testing the different scenarios like shading devices, and then we are choosing the best one can have a better impact. You can see the higher, actually, when it's getting higher, definitely the solar radiation can be more under this shading device. And another project, the last project that we did it is in Montreal, Canada. This project is a bit different from the other projects. It's using spatial climate analysis that can help us to perceive the challenge more clearly in a various dimension. So the measure that we use here, again, we use the technological tools and big data to create three-dimensional climatic model for the city of Montreal. So we choose a pilot area. Our pilot area is located in Montreal downtown. It's called Place Bonaventure. Here you can see some pictures that can give you some overview. And then, sorry. And then I'm going to introduce you this initiative that we started in Montreal. We started developing a model that performs through a computational platform called Solar Vision to optimize the climatic performance of the city from the various dimensions by applying spatial climatic analysis. This helps us to identify the hotspot, study them, and develop potential corrections, and then evaluate the most suitable ones. So we are calling this model 5-dimensional climate scenario model. Why we are calling it 5-dimension? Because this model is based on the 3D model of buildings, shading devices, trees, and topography. And the 4th and 5th dimensions are shaped along climatic and weather data of their location in different hours and seasons. So basically, this model will be able to provide a comprehensive platform for the city. It can document the existing climate stress in the city, where exactly the existing hotspots are located. And also it can help us to predict the improvement potential by developing different scenarios, as well as assess their climatic impacts on surrounding areas by placing the new designs into this model. So basically, when we are designing a building, maybe this building alone is completely sustainable, it has a perfect climatic performance, but as soon as we are putting this building in an urban area, it's showing completely different climatic performance. So it means that we have to see the whole system together. It's not just about one building, but whole urban areas, and how this single building can impact on the surrounding area and vice versa. And last but not least, this model can serve as a base for future construction projects, or one of the bases for granting construction permits that can be in the hand of the municipality, and try to use this model for these purposes. And also the overall goal of the project is a collaborative contribution to Montreal City towards becoming sustainable city as defined in the new urban agenda and the UN Habitat Sustainable Development Goals. As we already mentioned it, we are also constantly trying to promote sustainable development goals of United Nations in our projects. So in this project, we are trying to also concentrate on Sustainable Development Goal, or SDG number 13, which is climate action, SDG number 3, good health and well-being, SDG number 11, sustainable infrastructure, sustainable cities and communities. And also SDG number 9, to build resilient infrastructure and foster innovation. And number 17, strengthen the means of implementation and revitalize the global partnership for sustainable development. So what is important for us is implementation. We have to do some projects to implement them and take action. It's enough of the research and somehow come up with the solution and just putting in archive. So basically, we are trying to push the cities as much as possible to take action and implement the SDGs on the ground, and by 2030. So basically, this model enables cities to take accelerated and more ambitious climate action. This is our aim. We started this initiative in Montreal, and this project, as I already mentioned or not, I don't remember. In this process, I mean, it's still on the process, and we are trying to expand it in different parts of the downtown of Montreal. And as I already mentioned, we choose the Place Bonaventure as our pilot project. And how we choose it. To select the pilot project, we used remote sensing to somehow orient ourselves. We mapped land surface temperature, which can help us to have a general overview of quickly finding critical points of the city, the points that are exposed to the solar radiation and absorb more energy. So, and then we zoomed in and analyze the areas to find out where are the high risk areas, prioritize them, and then take it into the next level, which was development of the three-dimensional model. That you can see here is the Place Bonaventure. Here is actually a whole Montreal is somehow suffering from the hotspots, but we just concentrate on the downtown of Montreal, which is located in this part. And Place Bonaventure is one of the actually urban area in this downtown area. As I said, this is a pilot project, and we are trying to extend it for whole Montreal, whole downtown of Montreal. I mean, before we start mapping the climate on building skin and urban fabric, we try to analyze lots of climatic, we analyze lots of climatic analysis. And so this model has a strong, somehow strong, how to say it, strong scientific evidence behind that. I mean, the model that is coming out, and we already published it we are going to publish it in one of the books that is going to be in Japan. So actually, to find out the hotspots, we have to bear in mind is not the hotspot is not the spots that are just absorbing solar radiation. The spots, these hotspots are multiplying by direct solar radiation with the need for shade and shine. If we multiply these two factors together, we can achieve the negative and positive impacts of the sun, which is our hotspots. And then after analyzing that, we try to map it on urban fabric and building skin. Here is the hotspots here. You can see it. I mean, here you can see it better. That we found out where are exactly the hotspots. You can find the climate stress of the city. I mean, stress in cities. I mean, mostly the roofs and some parts of the urban area are suffering from hotspots. And you can also see the blue spots here are, I mean, the buildings create this shadow because of their certain orientation and volume. They were effective, and it could provide this shadow in really hot weather of Montreal. Basically, Montreal is suffering from extreme weather. They have a really hot summers and really cold winter. So it's a kind of extreme weather that we have to consider in our design. So basically, this is the model for this pilot area. We are going to expand it for whole downtown of the Montreal. This model can be in the hand of municipalities. And as I already mentioned, they can document the existing climate stress in the city, and they are coming out with different scenarios to solve the problem in these spots, hotspots, one by one. And also placing, this is really important, placing the new buildings into the model that can assess their climatic impacts on surrounding areas. Because as I already mentioned, a single building can perform perfectly alone, but as soon as we are placing in that urban area, showing completely different climatic performance. So we have to hold the system together and not just design a building and we say this building is sustainable and we leave out other surrounding and elements in that urban area. And also it can be used, as I already mentioned, by placing a designed building in this model. If it will show appropriate climatic performance, can get the construction permit from the, as one of the bases. We cannot say that just this this model can give you a construction permit. It can be as one of the bases to get a permission for implementation. And the next one, I would like to introduce one of the scenarios that we develop here. Here is one of the hotspots in Montreal, in that Place Bonaventure area. And then we try to integrate a different greenery with this shape and style. And we could decrease up to 5 degrees centigrade temperature in this part of the city. And you can see from different angle here, here's the hotspots, and by placing the greenery, we could decrease the temperature in this part of the city. Actually, Montreal or Canada in general is not suffering from the lack of water, so we didn't have a problem to integrate greenery as much as possible. So this is one of the advantage of having lots of water in our cities. So this model that we create could bridge lots of gaps. It could bridge the knowledge gap, empower the policy and decision makers to take a sustainable actions. It's not just about the decision makers, also practitioners, urban planners, or even students can use this kind of models to take a sustainable design and action, to make a sustainable design and take a sustainable actions in their projects. And it can also gap the technology, bridge the technology gaps. Basically, technological tools can help us to better identify our challenges, communicate better, prepare and manage any crisis in an uncertain and sophisticated environment. So in this regard, technology acts as a supportive tool to ease and facilitate the process of perceiving challenges in a very complex system. It can also bridge the scenario development gaps by prioritizing the scenarios by ranking different design choices according to their long-term effect. It can help us to actually find out the best solution. And also bridge the data gap. We are using the big data and capturing insights from various perspectives and motivate innovation by using big data is one of the, but actually we have to think about it that let actually data inform you, not lead you. And this is also really important. And data cannot tell you everything. You have to also use a different kind of approaches to actually complete that ways or approach. And the last slide, I'd like, take away. So I can mention some points here. Use the challenge as an opportunity to turn it into an idea. So whatever challenges exist in the urban area can turn to an opportunity. So try to see it from that perspective. Create a place that can respond to all aspects of life. As I already mentioned, is not just tackling issue and mitigate the urban heat island effect and just think about the environmental aspect. If you want to achieve the sustainable development goals, you have to consider all the aspects of life, economy, environments, and also social aspects. And also inspired by some, before you start designing, try to research what exactly traditional elements or traditional ways exist in that city that you want to, in that target city that you want to design, to be inspired and somehow integrated the solution that the people use for centuries to decrease their temperature, and you can integrate into your design. And as I already mentioned, bring the local people who are living there into the conversation, engage them, hear them, and among their conversation, you can find out what kind of even solutions, innovative solutions exist that you can integrate it into your design process, and also try to bring them around a table and co-create with them design processes, or I mean, you can see it from the architecture as well as from urban planning perspective or urban design perspective as well. And also apply it, as I already mentioned, the right solution in the right place. I mean, one solution cannot be perfect for all the cities around the world. So you have to see, based on the context of the city, which solution is perfect for that context. Also invest in a diversified portfolio and not to put all your investments into just one solution. Try to, as I already mentioned, try to distribute your eggs in different baskets to get a better response. And also, if it's possible, apply spatial climatic analysis to find out the exact hotspots or critical points in various dimensions to be able to take smart and sustainable actions toward the reduction. Thank you so much for your attention. And if you have any questions, I'm here to answer them.
Any questions?
That the funding is coming from the UN.
No.
Unfortunately, I cannot hear anything.
Where does the funding for these projects come from?
Sorry, can you ask
I'm
again?
gonna get close. I gotta get close. Okay.
Yes.
Where does the funding for these projects typically come from?
Yes, Emily, I mean, mostly my projects are with governmental organizations, municipalities, and sometimes a part is coming from some foundations, and also sometimes we are applying for budgets for, I mean, sometimes it's a call, we are applying for them. If we win, we are gonna get the budget to do them.
Thank you. Yes.
What's usually like the average duration for a project?
How long does it take you to design and build these projects typically?
Sorry, can you come again?
How long does it take to design the projects? How long does it take to build a project like these?
It depends. It depends on the size of the projects, and also for many other factors. It's not just we are saying, okay, 1 month we are going to finish that. But for example, for Abu Dhabi, took us 3 months to design that. But if you want to go to the implementation phase, it's completely different. It can also go until 1 year, maybe.
Thank you.
Any other question?
Yes.
Yeah, Anya?
What type of materials would you say you really like to use?
Yes, the material that we are using are mostly high albedo material, and we are actually suggesting high albedo materials, like the materials that, I mean, simply saying white materials. White materials are not absorbing lots of solar radiation, and they are reflecting actually the solar radiation into the atmosphere. And for example, I mean, in some cases, for example, in one of the Cairo project, there was a kind of beton building. Sorry, beton, I said it in German, a concrete building. And then we tried to just encourage the citizens to paint the facade of their building with a white material, with a white color. So the materials that you can use, it can come from natural material, nature, can come from the nature. As I already mentioned, the white materials, as well as, I mean, for example, the most, a negative one is asphalt, because asphalt is really dark and is also absorbing lots of solar radiation. And as I already mentioned, it can also reach to the really, really hot surface, and you can even cook the egg on top of that. Sorry?
Someone just said you could make a nice omelet in the morning.
Yes, exactly. You can actually watch some videos in YouTube. You can search it and you can see that how they're cooking eggs on asphalt.
Any other questions? No? Thank you so much, Parisa, for joining us today. We really enjoy your presentation, and I'm sure that students will integrate some of these design principles in their design project this semester.
Anya had
Yeah.
another question.
Anya has another question. Anya,
What was your favorite place to work in? Like, what was your favorite country?
what's your favorite place to work? Which city, which
Which
area?
city? Actually, more. I'm all the time looking for more challengeable target area. Like for example, Cairo was one of the really challengeable urban area. For example, in this unplanned area or informal settlement area was really challengeable. I all the time like to put myself in a challenge. I don't like to just work really in one line. I try to find, because I mean it's like a puzzle, and I like to put lots of factors together as a puzzle, and then when it's finished, I'm really happy with that. So that's why I'm all the time like to find out the urban areas that are more challengeable, because it's not about just design. There are lots of factors that can also impact.
Yeah, I know Parisa for more than 25 years, and she always was like that. She got her, bachelor and then master and then PhD and then postdoctorate and then some, fellowship here and there. And finally, she joined to United Nations Habitat to work with some policymakers. She looked for challenges, I know. And she's very, very successful, and I always admire her.
Thank
Now
you.
you're
So
gonna invite her to the review.
Sorry?
Yeah, come here and you can.
Oh, I have to, if you want to come to our final review? over
Yes,
Zoom,
of course. Why not?
We can
Why
do it
not?
over Zoom a
Yeah.
bit. Yeah, okay, good.
Good,
I'll have
great.
Dr.
More than
Souffle-
happy.
We send you,
Yeah.
Professor Tweed, we will send you an email. And you can join us for final review, final projects review.
That's my great pleasure. Thank you so much for your invitation.
No, any other questions? Yeah? Okay, thank you
All
so
right,
much.
thank you.
You're welcome. You're welcome. Thank you so much for your invitation, and maybe see you next time.
See you soon.
Have a
Bye.
nice day. Bye-bye. Bye.
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 Yeah, stop recording.
Yeah.
Make sure you want to stop recording.